What is up, Algebros? This is lesson 8.3. We're talking about population parameters. And you probably don't know what a population parameter is, but a population parameter is simply a number that represents the whole population. Now, generally, we won't know this exactly, and we'll have to estimate that based on a sample space, but there's a couple basic ones that we're going to start with here. And the first one is the population mean, or we use the Greek letter mu to represent this. And that's pretty much just the average of the sample. So if we were, pretty much what you do is you just find the average. So you add up all of the x sub i's, and then you divide by the total number. That's what all that means. This means the sum of all the x sub i's, or all the different data pieces. And then this is the total number here. And the other one is the population proportion. And we just use the little letter P to represent that. No cool Greek letter for that one, unfortunately. And that's just the number of a set. So maybe you're talking about number of people that have 5 kids or more divided by the total number of that. So let's go ahead and look at this here. What is the proportion? What's the population mean for the number of hours worked per day? So first off, we need to find out how many employees there are, and we need to find out what's the total number of hours worked. So if total number of hours worked would be 3 times the 4, then we need to add to that 4 times the 12, and then add to that 5 times the 21. That will give me the total number of hours worked, and then I need to divide that by how many employees there are. So it'd be 4 plus 12 plus 21. So you can see 3 times 4 is 12, 4 times 12, 48, 5 times 21 is 105. Add those up, you get 37. Add those up, you get 165. When you take 165 and divide it by 37, this is the total number of hours worked, and this is the total number of people. You get 4.459, so I'm going to say about 4.46 hours. So on average, their employees work 4.5 hours per day. Now, if we wanted to find out a proportion, we would probably want to talk about the number of people that work, say, over 5 hours, or that work 5 hours. So the number of people that work 5 hours is 21, and the total number we already found over here, which is 37. And if you say 21 divided by 37, you'd say 0.568 if you wanted to. So that's the proportion of people that work more than 5 hours. So we just wanted to see like how many people fit into that set, and then divide it by the total number of people there are. Now, accuracy of a sample set is something that's pretty important. If I were to survey how many people at the school like hot dogs for lunch, and I only asked 2 people, that wouldn't be a very accurate representation of the group of people. So we have to talk about the accuracy of my sample. I can say something about a sample, but is it actually accurate or not? And so the accuracy is based on 2 different things. The first one is just the margin of error, or how much off could you be, and then also the confidence level. We're going to be talking the confidence level later on, but today for margin of error, if we have a large population, then we use this formula. Plus or minus 1 over the square root of n times 100, or that's plus or minus 100 over the square root of n, and n is just the number in your sample, and that will tell you your margin of error. So it says, guide practice number 3 says a survey is conducted to determine the most likely color of the rainbow. The results of 200 people surveyed showed that 44% of the people liked the color blue the most. Find the margin of error. So since there was 200 people surveyed, we're going to say plus or minus, I'm just going to say 100 over the square root of 200. So that's going to be 100 plus or minus over 10 root 2, which is about 7.07. So since that's what our margin of error is, they said 44%, so it could be 44 plus that 7.07, or it could be the 44 minus the 7.07. So the real proportion would be between 36.9%, so I'm going to say between 36.9% and 51.1% is where the actual results would be, because we have this margin of error. So this would be our answer right here. A finance director decides to conduct a survey with a margin of error that's plus or minus 4%. Find the appropriate sample size. So he's conducting a survey and he says, I'm okay if I have a 4% margin of error, but I don't want to have anything bigger than that. So how many people should I have? How many people should he sample? So what he wants to do, or what we're going to do, is we're going to still use that same formula that we're using right up here. And we're just going to use this for it. So we want to say plus or minus 4% is going to equal to 1 over the square root of n times 100. You know what? I'm just going to do this. 100 over the square root of n. So to get that square root out of the denominator, I'm going to multiply by the square root of n over 100. I'm going to do this, multiply by the same thing over here, the square root of n over 100. That will reduce, that will reduce. The right-hand side just becomes 1. My left-hand side is going to be 0.04 square roots of n. Go and divide by the 0.04. I get the square root of n is equal to 25. Square both sides, and I get n is equal to 625. So his sample would need to be 625 people. Your homework is a worksheet, so make sure you get that, fill it out, and turn that in. I believe you guys are going to do awesome on this lesson. Good job, guys.